Standard RP2 includes RP2A, B, C, and D, and two of those standards, 2B and 2D, are part of the performance task of the MAP test. So this first standard, RP2A, this one just deals with, is it proportional? All of these standards deal with proportional relationships, and this specific standard is just asking whether it's proportional or not. And we can find if something's proportional or not on a table, such as problem number 2, by looking at the y value divided by the x value and seeing if it's the same. So let's label this table x and y. And it says the table shows the number of red flowers and blue flowers in several different bouquets. Are the two quantities proportional? Well, let's just take y and divide by x. So let's take 9 divided by 3 from this first ordered pair, which is 3. Then we have 15 divided by 5 from the second ordered pair, which is 3. Then we take this third ordered pair and we say 18, the y value, divided by 6, the x value, and we get 3. So every time we get the same value for y divided by x, so yes, it is proportional. The ratios of blue to red flowers are equal. Number 3, select all the graphs that represent proportional relationships. Well, they're going to have two qualities. First, they are going to be straight lines. So each one will be a straight line. And the second one, it goes through the origin, which, if we need a reminder, that's the point 0, 0. So let's see on each of these. This first one is a straight line, and it goes through the origin right here at 0, 0. So this one is proportional. The second one is not a straight line, so it's not proportional. This third one is a straight line, and it goes through the origin through 0, 0. So it is proportional. This fourth one is a straight line, but here's 0, 0, and it doesn't go through it, so it's not proportional. And then this last choice is also a straight line, but here's 0, 0, and it does not go through it, so it's not proportional. Number 6, a bakery lists the following prices for bagels. 1 bagel for $1.50, 2 for $2.25, half a dozen for $6.50, a dozen for $12. Is the price per bagel proportional to the number of bagels bought? Well, let's just look and see if all the bagel prices are the same, then they're proportional. 1 for $1.50, 2 for $2.25. So if I say $2.25 and divide by 2, I get $1.13, and right there, they're different. So the answer would be no. And I could keep doing this. I could say $6.50 divided by half a dozen is 6, and I get $1.08. And then a dozen for 12, that's 12 divided by 12 bagels, which would be $1 each. So no. And the reason we could say is that the prices vary for the number of bagels bought. Standard RP2B is about the constant of proportionality, and I'm going to put stars here. This is part of the performance task. And so the constant of proportionality is represented by the letter K. We could find K by saying that K is equal to y divided by x. Let's look at problem number 3. A graph has the equation y equal 2/3 x. What is the constant of proportionality? Well, the constant of proportionality could be represented in an equation where y is equal to k times x. In this case, we have y equal 2/3 times x. So the value of k, the constant of proportionality, is just replacing k, 2/3. We're done with that problem. Number 5, the values in the table are in a proportional relationship. What's the constant of proportionality? Well, remember, the constant proportionality k is equal to y divided by x. So we could see what y divided by x is every time. For the first ordered pair, that'd be 2 divided by 10, which is 0.2. And it should be the same for all of them. We could try 3 divided by 15, that's y divided by x, which comes out to 0.2. And it'll be the same for every case. We get 0.2 every single time. It's really unnecessary to test it for all because we're already told that it is proportional. And so the constant of proportionality is 0.2. Number 8, the graph shows the number of meters Jenny runs relative to the number of minutes she runs. What's the constant of proportionality? Round your answer to the nearest hundredth. Remember, the constant of proportionality k is equal to y divided by x. So we've got this ordered pair here, x and y. So I'm going to plug it in. 100 divided by 6, and we get 16.6 repeating. Notice that it says round to the nearest hundredth. So that'd be 16.67 when we round, and it is in meters per 1 minute. Also notice that we could figure out right here at 1 minute how many meters that is, and it's almost 20, and it should match this 16.67. Standard 7.RP.2.a-d is about equations for proportional relationships. Remember, these are going to be in the form of y equal k times x. So let's look at number 1. Which equation represents a proportional relationship? Well, the first one doesn't work because of that plus 2. The second one doesn't work because it's dividing by x. The third one doesn't work because it's got that exponent of 2. Now this last choice, we have 6x over 7. We can actually pull the fraction out from in front of x, and we get 6/7 x. If you have x in the numerator, you can always do that. And since that's in the form of y equal kx, then D is a proportional relationship. Number 7, the values in the table are in a proportional relationship. Write an equation to represent this relation. Well, we want to find out what k is, and we know it's y divided by x. So let's take that first order pair, 7.2 divided by 3, and we get 2.4. We could test another one and see what it comes out to. We could try 9.6 divided by 4, and it comes out to 2.4. And every single time it's going to be 2.4. So, in the form of y equal k times x, we get y equal 2.4x. Number 9, 3 friends are at a carnival. Beth goes on 2 rides for $5. Zane goes on 5 rides for $12.50. Jean goes on 6 rides for $15. Write an equation to represent the cost of the carnival rides. Well, notice every time that you take the amount of money spent on rides divided by the number of rides, you get $2.50 each for each ride. $12.50 for 5 rides would still be $2.50, and $15 for 6 rides would also be $2.50. So the cost, C, is equal to $2.50 times the number of rides, R. Part B, how much does it cost Tina to go on 9 rides? Well, C is equal to 2.5 times 9 rides, or it's $2.50 each. When we multiply that, we get 22.5, which would be $22.50 for 9 rides. Standard 7.RP.2.a-d is the last standard that would be part of the performance task. And it's still about proportional relationships, but it's specifically about the meaning of points on graphs within proportional relationships. So we're going to explore some characteristics of that. Number 1, George has a graph of a proportional relationship. Which point should he look at in order to read the unit rate? The unit rate is always going to be something over 1, or it's going to be where the x value is 1, and we have some y value that we don't know. And so answer choice B. Number 2, The graph below shows the amount of money Anthony earns relative to the number of hours he has worked. So what's the unit rate? We know that's where x, the number of hours, is 1. So let's see what y is. 10. It's $10. And so for his salary, that means we're talking about $10 per 1 hour. Part B, how much does Anthony make if he works 8 hours? Well, we know it's $10 per hour, so we're going to multiply that by 8 hours, and that would be $80 for 8 hours. Number 6, the graph below shows the number of folders relative to the number of boxes. How many folders are in one box? So we have boxes. We go over here and see there's 1, and go across, and that would be 20 folders. So 20. Part B, what does the point 360 mean in this situation? So 360 would be right here. And 3 would represent the boxes, and 60 would represent the number of folders. So we could say something like there are 60 folders in 3 boxes.